In this lesson, 6.3, reverse distribution, factoring algebraic expressions, you will have learning goals. Over here, use the distributive property to factor expressions, combine like terms to simplify expressions, and then also on the right here, you have some key terms that you need to make sure you're adding to your vocabulary as you see them throughout this lesson. Don't forget to go back and add those to your vocabulary list. Please read along with me as I read the intro. Many beginning drivers have difficulty with driving in reverse. They think they must turn that wheel in the opposite direction of where they want the back end to go. But actually, the reverse is true. To turn the back end of the car to the left, turn the steering wheel to the left. To turn the back end to the right, turn the wheel to the right. Even after mastering reversing, most people would have difficulty driving that way all the time, but not Rajagopal Kawindar. In 2010, Kawindar set a world record for driving in reverse over 600 miles at about 40 miles per hour. All right, so here's a very crude picture of a car, and it's wanting to back into this space back here to its right and behind it. So you'd have to actually put the car in reverse, and you want to go to the right, which most people would think, well, we're in reverse, so I want to go to the left. But actually, that's not true, because if you turn your steering wheel, so this is our little fake steering wheel up here, if we turn that to the right, then it actually makes our tires go towards the right, and when we reverse, our car will just go in that direction wherever our wheels are pointing. All right, so in this lesson, problem 1, factoring, you can just use the distributive property in reverse. So if you consider the expression 7 times 24 plus 7 times 14, since both 26 and 14 are being multiplied by that same number, 7, the distributive property says that you can add those multiplicands together first, then multiply their sum by just 7 once. So what does that mean, multiplicands? So you can actually take out that 7, so you have the 7 multiplied by each one. You can actually put that 7 outside the parentheses now, and you can add the 26 and 14, the numbers that are left over, first. Those are your multiplicands, by the common factor of 7, the greatest common factor of 7. You have factored that original expression. To factor an expression means to rewrite the expression as a product of factors. So just think about multiplying. What do we call the numbers that are multiplied together when we are to get a product? Well, we call them factors. So that's really what we're doing. We're seeing what is the common factor here and pulling that out. So the number 7 is a common factor of both 7 times 26 and that 7 times 14. A common factor is a number, or it can be an algebraic expression that is a factor of 2 or more numbers or algebraic expressions. So let's look at that. Think about when we had fractions. So when we had a fraction like 4/6, remember when we would find the greatest common factor to try to reduce that fraction? So for instance, in this one, you can divide out 2. That is your greatest common factor, because 2 can be divided into 4 and 6. And this would be reduced to 2/3. You're kind of doing something similar to that. You're kind of dividing out that greatest common factor, but now it's not a fraction. You've just got these two terms that are being added together. So let's try it out. Okay, so first we want to find, and number 1, it says factor each expression using the distributive property. All right, so we need to find their greatest common factor. Okay, so we can see right here that 4 is the common factor here between both terms in this problem. So we can divide out the 4. We can pull that 4 out, factor it out. And inside, what are we left with? Well, we still have the 33 and the 28. So we're just going backwards from before, from last lesson. So let's go ahead and we have left 33, and we carry down the minus, and we have the 28. And we just work backwards. So instead of going, so now we're going from expanded form back to what we call factored form. Whereas before, you were taking the factored form and we were expanding it out. We were getting rid of those parentheses. You can actually use this property both ways. You can have expanded form, where they're already multiplied out, and take it back to what is called as factored form. So try this in B. I want you to pause the video and see if you can find the common factor. So hopefully that you got this answer. If you have any questions, please let your teacher know. All right, please read along with me. The distributive properties can also be used in reverse for factor algebraic expressions, which we just talked about. For example, the expression 3x plus 15 can be written as 3x, so 3 times x, plus 3 times 5, or it can be written as 3, the quantity, x plus 5. The factor 3 is the greatest common factor between the terms. The greatest common factor, or the GCF, is the largest factor that the two or more numbers or terms have in common. So when factoring algebraic expressions, you can factor out the greatest common factor from all the terms. So consider the expression 12x plus 42. The greatest common factor of 12x and 42 is 6. Think of the multiples of 12 and 42. Therefore, you can write the expression as 6, the quantity, 2x plus 7. It is important to pay attention to the negative numbers. When factoring an expression that contains a negative leading coefficient, or first term, it is preferred to factor out that negative sign. A coefficient is the number that is multiplied by a variable in an algebraic expression. All right, there's a lot of vocabulary here that you're going to just kind of use. We know what greatest common factor is. Again, we talk about that when we simplify fractions. But they're talking about here, what if you had a negative number in the leading one? So what if you had negative 3x plus 15? Okay, there's a negative leading here. Typically what you'll see in algebra is they like to factor out that negative as well. And we're going to learn how to do that. And they also talk about here, what is a coefficient? A coefficient is the number that's multiplied by the variable. So remember, we said if two numbers are right next to each other and they have to be in parentheses, that means multiply. But whenever you have a variable right next to a number like this, that's multiplying. And that number in front of that variable is called your coefficient. Okay, so let's take a look here. Look at the expression negative 2x plus 8. You can think about the greatest common factor as being the coefficient of negative 2. So in negative 2x plus 8, you can take out negative 2 because two negatives make a positive. So think about that. You have a positive 8 there. So if you factor out negative 2, the other factor has to be negative 4. So now when you factor out negative 2, the negative 2 is outside the parentheses. Now that's your x is still there. But what happens? Your plus is now, look at that. It's now become a minus because of that minus 4, which remember, you could write it as plus negative 4. It's the same thing. Remember, you could still write it as the quantity, negative 2 times the quantity of x plus negative 4, and still keep that plus with that negative 4. But most of the time in algebra, you're going to see it written as x minus 4. It's just a simpler looking at it that way. All right, so let's practice factoring. I'm going to again try one with you, and then I'm going to have you try a couple on your own. So let's try A. what is the greatest common factor between 7x and 14? Well, x is not in both terms, so we can't factor that out. But 7 goes into 7 and 14, so we can factor out 7. And you're left with x, 7x, and 7 goes into 14 2 times. So if you multiply that, you can always check it by multiplying again. 7 times x is 7x, plus 7 times 2 is 14, which takes us back. Now I want you to try the next B, C, and D and see what you come up with. Okay, so let's look at B, C, and D. The only one, I want to really look at C and D real quick. If you notice in C, it wasn't just the number in front of the variable, the coefficient, that we factored out there, because 10 is not a factor of 25. Only 5 is the greatest common factor between the two. So if you factor out 5, 10 divided by 5 is 2. So you still have a 2y remaining. And of course, 25 divided by 5 is 5. So you still have a 5 remaining in the second number. So the greatest common factor is not always the number, the coefficient to the variable. It could be a different factor involved there. And then also look at D, same thing. The greatest common factor wasn't 8. It was 4. So you can only divide out 4. 8 divided by 4 is 2, so you have 2 in left. 28 divided by 4 is 7. All right, so this last two I want to go over real quick. Here you're going to see that your coefficient has a greatest common factor, but you also have an x squared and an x. Well, remember, x squared really just means x times x. And both of those are factors. So in x squared, you have an x factor. Well, in our other term, we also have an x factor. So we're going to want to factor out the coefficient first. Let's see what we can get factor out there. We know we can factor out 3. But we also have an x squared that has a factor of x and a 21x that has a factor of x. So we can also factor out an x. And what do we have left? Well, we divided out 3, so 3 divided by 3 is 1, and we don't put a 1 in front of the x. The coefficient is assumed to be 1 if there isn't a number, so we're just not going to write the 1. And then, well, if we divide out an x out of x squared, well, the other factor is x, so you still have an x left. So again, I'm not going to write a 1 in front of that x. That 1 is just assumed. And then we copy down our minus. And we say, okay, well, 3 divided by 21 is, or 21 divided by 3 is 7. And we divided out our x. X divided by x is 1. And this is what we have left. So I want you to try this on F and see what you come up with. All right, so let's check this. You have a 6 in common with 24 and 18. So you can take out a 6. And remember, a squared is really a times a. And you also have an a in your other term. So you can factor out an a. That is also a common factor between those two terms. So if you take out a 6a, then now you really have 6a times 4a. Okay. So you really have 6a. If you factor out 6a out of 4a and 6a out of 3, you now have a common factor of 6a that you can pull out, and now you have 4a plus 3 left. Okay, so you can do that for any of them. Okay, so let's try G together. So let's see what we have in common. Let's look at our coefficients first. Well, we know 5 goes into 15 and 35. So we're going to break this apart just to make this a little bit easier to see, especially in the beginning here. So we know this, a 5 can be taken out of that one. But they also have an n factor. Hopefully you can see that. But they also have this n right here. And since both of them have n, we can factor out n. And let's just I want to write this one out in detail. So if we take out 5n here, we still have 3m. Because n divided by n is 1. 15 divided by 3 is 5. Okay? But we still have that m. We didn't factor that out. Carry down our minus. And now 35 divided by 5 is 7. N divided by n is 1. So we still have that. And finally, let's try h together. We now have a negative in front of there. So remember, we don't want to have a negative at the beginning. We want to get rid of that. So we're going to factor out at least a negative. And 3 goes into 27. So we're going to factor out -3. Okay? And we'll still have an x in that term. Plus, if we plus, we'll have, well, actually, it's a minus. So let's, okay. So now it's a minus still. And if we take this -3, okay, and so this would have to be -9 to keep that a positive 27. Okay. All right. So let's take out that -3. We still have an x minus 20. I'm sorry, minus a -9 minus a -9. And now remember, if you have a minus, using our keep, change, or add the opposite, or our KISS as we call it in my class, x minus a -9 is really x plus 9. You're going to see it written like this most often. Okay, so now I want you to go and try I on your own. Okay, look at I real quick. Again, you factor out that -6, and now you would have -6, and then in parentheses in that quantity would be x plus, well, you'd have a -5, because -6 plus times -5 is a positive 30. But again, to make it a little simpler so you don't have that plus and negative, we can also change it back to a subtraction so it's just a little simpler looking, but either one works. So now you would just have -6 quantity x minus 5. It's just a lot of times in algebra you're going to see it written so it's not a plus and a negative right next to each other. All right, so now we're going to use, in problem 2, use the distributive property to simplify. So far, the distributive properties have provided ways to just rewrite given algebraic expressions in equivalent forms. You can use the distributive properties to simplify algebraic expressions. So consider the expression 5x plus 11x. What factors do the terms have in common? Well, hopefully you said x. All right, so let's rewrite it, factoring out that x. If you take out x, you now have left 5 plus 11. All right, so how could we simplify that? Well, you still have your x, and if you had 5 plus 11, well, we know that's 16. Now, we always write the coefficient in front, so let's just switch those around, and now it's simplified. The terms 5x and 11x are called like terms, okay? Meaning their variable portions are the same. When you add 5x and 11x together, they are combining like terms. So whenever you see an x, the same variable to the same power, you can add their coefficients. They're called combining like terms. So let's do 4a together and see if we can combine in these like terms. So on 4b, you probably noticed that the coefficients do have greatest common factors. You can at least see that they're both even, so there'd be 2. But right now we're just focusing on combining like terms. So that means, if you notice, in b, they're both x squared. So they both have the same set of variables to the same power. So we're just going to factor out that variable right now. And now you can subtract, since this is a subtracting problem, the coefficients. Well, we know 32 minus 44 is really 32 plus a -44, which is really -12. And we put that in front of our x squared. So you probably don't want to go through doing the distributive property every time you see a like term. But hopefully you saw the pattern that every time you have 2 terms, which is terms, what I mean is something that's being added, or subtracted. And if they have the same variables, same set of variables to the same powers, you can just add or subtract their coefficients and keep the variables. So let's simplify. Number 5 says, simplify each algebraic expression by combining like terms. If the expression is already simplified, state how you know it. All right, so let's do that. Go ahead, and we know that the greatest common factor of 6x plus 9x is 3. So if we factor that out, you have a 2x. Oh, what am I doing? Sorry, guys. Scratch that. We're not doing the coefficients. Remember, we said we were doing the variables. So if we have, sorry about that, if we're simplifying here, we just said we have like terms, both x's, so we're going to add the coefficients, 15, and keep our variable, which is x. I want you to try that with B, C, and D. Okay, so take a look at the answers here. I had to change one of them. I think G was incorrect in the answer guide I had, so just take a quick look. I wanted to point out D, F, G, and H. If you notice, I color-coded different terms that were not like terms. So like in D, it had an M and N, but in the 8 M and N, but then the second term only had an M. So you might want to color code or circle or square or something so you can see the different kinds of like terms. Okay, problem theory is just more practice. So just be careful when you're factoring, when there's a negative out front. Remember, when you factor out that negative, like in problem 3, so we're going to factor out a -8 as our greatest common factor, and we don't have a variable because there's an x and a y, and they're not in common. That when you do that, now you have, it was -24, so now -8 times 3, and you have that 3x. That plus in the middle, that just basically, when you factor out a negative, it makes that the opposite inside there. So now it would be, if you factor out the 8, 16 divided by 2 is, or 16 divided by 8 is 2. That plus just becomes a minus because you're factoring out a negative. Everything becomes the opposite inside the parentheses. So for the sake of time, here's all. Sorry about that. Shouldn't have shown the answers. For the sake of time, I want you to go answer these and then start the video again and look at the answers. That will show in just a second. Okay, sorry about that. So now I'm assuming that you have done them, you're checking your answers. As you can see, these are pretty long problems, especially like 2A, that's a big one. They wanted you to evaluate it with the factored, and then factor it and try it. So 2 different ways of doing it. And you can see which way is your favorite way, whether it's not factored or factored. It sometimes can be easier, and that's what they're wondering. So in C, you're just asking yourself, which form, simplified or not simplified, do you prefer to evaluate and why? Okay, so on problem 4, again, to save time, so you're actually doing most of this work. Problem 4, again, you are going to combine your like terms, so you might want to do the color coding like I did in the other problems. You may need to distribute first, like in B. I'm going to warn you there, you cannot combine like terms until you distribute. So make sure, I'll show you, you would put the -5 through the parentheses, so -5 times 2x will give you 10x. And then if you multiply 13 times 5, that is 65. And remember, that minus becomes a plus because we're factoring out a negative. And then since we're done with the parentheses, we just copy down that minus 7x. Then you can combine like terms. So you have to distribute first before you can combine like terms. So now finish the problems and check your answers, and pause the video and then check your answers. Okay, so here again is the steps and the final answer that you should have. All right, so problem 2, it says, or for part 2, evaluate each expression for the given value. Then combine the like terms in each expression and evaluate the simplified expression for the given value. So you're going to evaluate it. What does evaluate mean? It means plug in for x, whatever value they have there, 2.4. And so you're going to evaluate the expression first. Then you're going to combine the like terms in the expression and evaluate the simplified expression. So you're going to do this 2 ways. You're going to do it one, the way it is up there, and plug in for x for 2.4, or 2.4 for x. So for x, that becomes 2.4. minus 12 plus 3 times 2.4. But then the other way, so then you're going to simplify all that. The other way they want you to do it is to actually combine like terms. So your x's would give you negative 2x minus 12, and then plug in from there, negative 2 times 2.4. Remember, you're using your calculator on all these, so you shouldn't have any problems. And then what you want to do is say which method is actually easier. Okay, that's what they're looking for. And it's all your opinion. Okay, so pause the video and see and work it out and see what you. Again, so here's the solution both ways with both methods. Check it out and see which one you like. 2B is an optional one. If you want a really big challenge, go for it. But this one takes a while to do, I will warn you. So this is optional to do. I'm going to show you the answer, so pause the video, and I'm going to show you the answer now. Now you can see why it was optional. It was extremely long to do it both methods. So hopefully you've had enough practice here on factoring, and now you can go do your skills practice.